So next up, the fourth of these 6 specific outcomes under developed trigonometric reasoning, it is expected that students will graph and analyze the trigonometric functions sine, cosine, and tangent to solve problems. So this is going to be about graph interpretation. The good news is the graphs of sine and cosine are very similar. Really, the only difference is a little bit of a phase shift. So you could actually say that the cosine graph is the sine graph, but shifted to the left. So that the sine, which naturally comes up through 0 at 0 and then peaks, gets translated or moved so that it peaks at 0 and then continues. We've got nice, clean domain and range here. The domain is all the real axis. Every value is allowed. And until we start multiplying or adding, our range is just between plus and minus 1. The tan function gets a little bit trickier. So because it's a ratio, we get these kind of smooth curves here with these periodic asymptotes. So this one is going to take a little more involvement. Now you could be thinking, hey, we just learned that there's 6 trig identities here, or trig functions, and yet we're only going to have to graph 3 of them? Well, no, you are going to have to graph all 6. Because really, what is the difference between graphing cosine and 1 over cosine? It's something that you will need to deal with, but that's just graphing secant. So when they say you have to deal with all 3 of these, the sine, the cosine, and tangent, they could, in theory, say you only have to deal with 2. And just say, no, you just have to deal with the sine and the cosine. But oh look, now you're graphing tan, because sine over cos equals tan. So we are going to learn how to graph all 6. Now the secant and cosecant are a little more troublesome. If you have your axis here, they're also going to have asymptotes, just like tan does, because these guys have a range where they are less than -1 or more than +1. So it's the reciprocal of all values between sine and cosine. So where the sine would, say, be a positive value, coming in, cross 0, and then become negative, the cosecant, which is the reciprocal of that, well, as sine gets smaller and smaller, the reciprocal gets bigger and bigger and bigger. When it jumps from positive to negative, as it goes through 0, it's going to come down here. So graphing the secant and cosecant is going to take a little more thought and effort. The fact that they are periodic functions does help us out a lot. When the function is periodic and it repeats exactly as it is over and over and over again, that gives you a bit of an advantage as you're planning ahead, because you just need to figure out what one period looks like and then copy that pattern over and over and over.